My name is Jesse, and this is my oral report. So I am on the Castle Builder team. So basically, our project is constructing a platform in the web browser. The user can go to build a castle in 3D space, and then they will have a simulation where they siege the castle. I was tasked with developing the UI for actually doing the building. So the first problem I ran into this semester was how do you actually get something that you click and drag it and put it into the game world. So this click and drag concept. There's already a lot of problems that you can imagine with this. The first one that I ran into was how do I determine depth, right? So like a mouse pointer only works, it goes up and down. It doesn't go into the background in the 3D space. So let's say I wanted to put a structure, you have your camera here. Let's say I wanted to put a structure here versus here. How do you do that with a mouse, right? You can't really do that. There's other problems such as what about building vertically? If I have a structure here and I want to put something on top of it and I move my mouse over this structure, how do I know that the user wants to put something on top of this structure, right, rather than behind it, because your mouse goes over it and you could be meaning behind it. And there's a lot of other problems, but this was really the main one. The solution that I arrived at after some trial and error was do this in 2 dimensions, right? Scrap the 3-dimensional idea. That's totally not going to work. So then the question becomes, how can I do this in 2 dimensions? And what I ended up doing was I built a grid, and you just drag 2D sprites onto the grid. And this takes care of the depth problem because you're now looking at a grid of the play area top down. So you can instead just, if you want something, you can obviously just put it anywhere on the grid. And then you have the problem of verticality. How do you build upwards? Well, that's solved by allowing each grid space to be stackable. So I can take a material, put it in a space, take another one, put it in the same space, and that means, build on top of it. This would eventually translate into the 3D rendering by basically I would serialize this data that is in the grid. So you build it, and then you hit build simulation, and I would serialize all the data that's in the grid into a 2-dimensional array of arrays, and then the inner arrays determine the verticality, and obviously the 2D array determines the position on the map. And so ultimately the simulator would deserialize this data and then build it using scripts. And this ended up being way better. The results were very good. This actually took quite a while for me to do. So the other team that was doing the simulation, I actually gave them mock data, just some object that I had set up that they could use to unpack it. And this ended up being actually a really crucial element for next time, is to be able to provide mock data for the other teams, which also brings up the need for teams to declare what they might require for the tasks that they're working on. And so we're already thinking about, going forward, if there are tasks where you need something from another team, you should say that up front, and also vice versa. If you need to give someone some either mock data or some information, you should do that up front. The results, other than being good on the simulation side, the actual script for dragging and dropping ended up being very complicated. And part of the reason is there's no tutorials or really exact scenarios like this as far as using Unity, which is new to me and to the other team members. So I think then in my research, when I was figuring out how to do the drag and drop, I found out that basically the 2D was the only way the whole time. The 3D thing was totally never going to work. And I think going forward, looking at that documentation ahead of time would be very beneficial, because if I had known that the 3D version would have basically not ever been able to pan out as far as my understanding of Unity, then I would have never gone down that path, and I could have just started off with the grid. So that's going to be very important going forward. And lastly, I think the knowing, basically coming up with a solution led us all to be able to determine, well, so now we know exactly how the system is going to work. This is our project. This is the core functionality of our project. So now we are able to basically get things rolling as far as defining tasks for the whole rest of the semester. And I think if we just stick to, we keep having these meetings, right, and to figure out these problems, and we know exactly what we're going to do, I think these problems will be very much so mitigated in the future. But that's it. So thanks for listening.